Okay, so what we've done with PHP so far, we've looked at the basic language and we've looked at how to create a form. Today we're going to look at how to take information from a form and handle it in a PHP script, how to stop certain types of common attacks against a website, and three, how to handle sessions with a browser. Because as I explained the first day when we got into PHP, as soon as you send a page back to the browser, you lose all your program state. It's not like a regular program where you have variables that retain their values and you're able to talk back and forth between the browser and the server. No, when the script sends the page back, the script terminates and all state information is lost. But obviously, you would like to keep information about that session, and there are multiple techniques people have developed for doing what is called session management. So today, three things: form handling, stopping certain types of hacking attacks, and session management. So we're going to start with forms, and get this to come up. So last time we saw how to set up a form. The two things to remember from last time are actually three things. First of all, on the browser side, you set up a form using the form element, and then inside the form element, you put your various widgets for collecting information. So that's one. As part of the form widget, it has two attributes. One is the method for transmission, post and get. And we went over that last time. I won't repeat it this time. The second is the action attribute, and that specifies the name of the script that should be invoked when the form is submitted. So this is going to be a script that executes on the server side. So in this case, we're saying on the server side, a form called process.php should execute. Since there's not a URL here, it assumes that the PHP file, in this case, exists in the same directory on the server as the HTML page. The third thing that is important is that when you are dealing with PHP, doesn't seem to be true of other scripting languages like Perl, but when dealing with PHP, if you want to have multiple selections, then you're going to have to put a pair of square brackets at the end of the name for that form element. There's typically only two widgets that provide the opportunity to make multiple selections. What are they? One is obviously a menu. What's the other one? Checkboxes. If you leave the square brackets off of the name, then for PHP only, you will only get the last selection. So for example, in this menu, if I had selected Alabama, Alaska, and Arkansas, the only selection I would get would be Arkansas. So don't forget to put those square brackets there. With checkboxes, you can do one of two things. You can either name each checkbox a different value. So in this case, each of our checkboxes was given a different name, which obviates the problem because you simply check the name of each checkbox. But if you use the same name for all four checkboxes, you would need to put the square brackets after the name, or else you would also only get the last selected checkbox. This is only true, as far as I can tell, for PHP. It's an oddity. I don't quite understand why, but it is what it is, and you need to remember that. When the form is transmitted, the name attribute is the way that you will access this particular form element's value in the script. So every scripting language essentially takes the form data and converts it into a dictionary. And that dictionary can be accessed, and the keys in the dictionary are whatever names you have given to the form elements. So the name attribute is a crucial attribute in form elements. And then the value is what shows up as the value for that key. So when you hit a submit button, so forms typically have, I didn't go over this because it was in the notes, but forms typically have a submit button of some sort. I'm not actually sure that this one does. Here it is, the submit button. So when the submit button is hit, the information is automatically packaged up and sent to the server. And the way that is done is through something called the Common Gateway Interface. Which you'll typically just see abbreviated as CGI. So it's the standard way for a client to communicate with a server. And so it's the standard way. Whoops. Whoa. Uh-oh. Okay, and the second thing is, so it's how the form data gets transmitted. So standard way, basically, for transmitting form data. Okay, so I'll say specifies how form data gets transmitted. And you'll remember that we went over that with how URLs can be constructed in order to send form data, with the question mark separating the name of the script from the key value pairs. So then scripting languages that are used as servers or for server-side scripting either have built-in support such as PHP, or they have a module like PHP that convert the form data to a dictionary. So back-end scripting languages, or server-side, let me say server-side, okay, have some means to convert form data into key value pairs. And place them in the dictionary. As I said, in PHP this is built in. In Perl there is a CGI module that you import, and it understands the CGI interface and does this service for you. In PHP, so PHP's form handling, you have 3 dictionaries that could contain the form data. There is $_get, which, as you might imagine, contains data that was sent via the get method. So it contains key value pairs. Okay, $_post. I won't repeat it, but contains key value pairs transmitted via post. And then there's $_request that essentially combines $_get and $_post. Okay, so if you're unsure of the transmission method, you could just use $_request, and it also would handle the case where you change the transmission method at some point in the HTML script. It wouldn't require you to go back and change all your $_gets to $_post or vice versa. So these dictionaries contain that information. If a form element returns multiple selections, it does so via an array. So back here we had that the name of this menu was state. So in my PHP post, I could do something like, say, for each $_request state as $state, and because it's coming back as an array, I could now do process each state. Okay, now if the form elements differ as to what they transmit if they are not selected. So what gets transmitted? Okay, if a form element is not selected. So for a text element, it is the empty string. For a radio button, and I believe also for checkboxes, nothing gets transmitted. So the form element will be undefined. Okay, the key associated okay. And there's ways that you can check. There are functions you can use to check to see if a key is defined in a dictionary. I believe for a menu that it is also undefined. So I'm going to say that the same is true of a menu, that nothing gets transmitted. Okay, so you need to check and make sure that something exists before you actually go and deal with it. Okay. The second thing is, as I said, you cannot trust what you receive from the browser. So in the browser, you typically type check also. The reason you type check is because you don't want to make a round trip to the server with invalid data. Basically, you don't want your server having to pull double duty. If you can do some type checking on the client, you do, but it's for the user's benefit. If the user enters an invalid zip code or a telephone number, you want to let them know immediately. For the same reason, we use radio buttons and checkboxes in menus, not because we can foil a hacker, but because we want to prevent a legitimate user from making mistakes. So the front end, the client side, the type checking we do over there, the form elements we use to prevent mistakes, is all irrelevant to the back end. It's there for the convenience only of the user, so that the user doesn't make mistakes. When we get the data on the back end, we must assume that it is not valid, that a hacker may have gotten their hands on it. So the first thing you must always do is type check the information on the back end. You can't assume the front end has type checked. So always type check all client transmitted, or type check all form data, because a hacker may have corrupted it. Okay. Now that's not good enough, because sometimes you're expecting just a normal string. A good example of that is blog posts or Facebook posts. All you're expecting from a Facebook post or a blog post is a string. You would think there's no need to type check that. But there are other things that a hacker can do, and so you have to do other things to stop two types of attacks. The first type of attack, so also additional things to stop attacks. First of all, you need to know what the attacks are. So there's two types of attacks that we're going to talk about, two types of common attacks. There's far more. There's a web security course that will probably be offered in the spring that will go into detail about how you deal with web security. We're just touching the tip of the iceberg here. So two types of attacks that we will deal with in this course. The first is cross-site scripting attacks. Okay, and it's essentially an HTML attack. The second is database or SQL injection attacks. Okay, so a cross-site scripting attack is one in which a malicious user is attempting to alter the web pages you send back to the user so that the user will, an unsuspecting user will access sites that they normally wouldn't. So cross-site scripting attack, it's best I have a good definition for it here, so rather than repeating it. Okay, so Wikipedia had this. It's a type of computer security vulnerability found in web applications which allow code injection by malicious web users into the web pages viewed by other users. It's really HTML injection into these web pages. And a good example is from the notes. So let's say that we do have a forum and people are posting comments to the forum. So they're coming in as strings. If you just let's say the post comes back as you see right here. So this is the post that some hacker sends to you, and you send this post back out into the forum. Okay? When this post comes back out into the forum, it will appear as a link. How do I know that? Because this is the tag for a link. This right here is a JavaScript command that gets executed when a naive user clicks on the link. The JavaScript command, as you can see, is inserting a URL, www.downloadvirus.com, and it is inserting it into a part of the document. There's what's called a document object that is sitting behind the web page, and that document object has a location attribute. The location attribute points to the page that is being displayed. If you change the URL for that location attribute, the web page, the browser will automatically load the new URL. So in this case, if a naive user clicks on this link, the JavaScript command will load this new URL. The browser will see it and load this page, and presumably will start downloading viruses onto your computer. Okay, and as you can see, they finished it up with a very innocuous label for that post, which was sort post by date. Looks like a very useful link that many of us would like to click on. You might think, well, I'd never be that stupid. Well, it turns out that it takes something like 1/1000th or 1/10,000th of a % of naive users to make these kinds of attacks profitable. I once saw the statistics. It was mind-blowing how few people had to actually click through in order to make these attacks profitable. So they don't need a huge buy-in. Okay, but this is an example of what's called a cross-site scripting attack. They've sent you a string, looks like a perfectly nice string, so you just post it back out to the forum. But because the string happens to be HTML markup, and that markup contains this, I guess you would call it code injection, something bad is going to happen if the user clicks on the link. So we would like to stop this kind of attack cold in its tracks. There is a way to do that. PHP provides a number of commands. In this case, the command is HTML entity encode. Right there, HTML entities. Okay, what it does is it returns a new string where every XHTML character has been converted into what's called an entity code. So let me show you first what it does, and then we can talk about it. So I'm going to create a nasty string. Nasty equals a on click equals do something. We'll say document dot location equals, I'll just arbitrarily put something. Okay, so that's the nasty string. Now I'm going to defang it. So I'm going to set nasty equal to HTML entities nasty. Notice it won't do it in place. It's going to have to be, it creates a copy of the string, replaces all the HTML characters, in this case the less than, with what we call entity codes. If we now run this, do I have to what? Oh, I know what you're talking about. Thank you. Okay, and as you can see, instead of a less than, there's now a ampersand LT here. And over here, there's an ampersand GT. And here there's a ampersand LT. And here there's an ampersand GT. And then there's a semicolon after them. Those things are called entity codes. And when a browser sees that entity code, it replaces that entity code with the corresponding symbol. That's also how you can get special characters like pi or Greek letters. You can just Google entity codes and you'll see a whole list of entity codes that you can put into an HTML document. But this string has now been what we call sanitized. If I send this string back to the browser, it will appear normally, but let's actually do it. So now let's see, actually let's copy foo.php to my, actually let's just, easier if we do this, show you what happens. Okay, so now I can run this puppy. And as you can see, it foils the attacker because the user literally sees what the attacker tried to do to them. The browser has interpreted each of the entity codes as and replaced them with their appropriate ASCII character, but it has not interpreted those ASCII characters as HTML markup. So rather than this hacker's post appearing as an actual link, the user sees exactly what the attacker had in mind for them. Okay? So, bottom line is that you use HTML entities, use the HTML entities function to eliminate harmful HTML tags. What it does is it converts those HTML tags to their entity codes, and that stops it in their tracks. Okay? This HTML entities function has a converse or inverse function that is called HTML entities decode. So you can take one and actually have it return a string where all the entity codes have been replaced with their text equivalents. So many of you took CS102 from me or from Dr. Berry or Dr. Holt and used Code Assessor. So Code Assessor has an issue where it needs to transmit code that you view, right? So you might have some code that looks like this. Let's see. # include IOStream using namespace std. Okay, and you might have if A less than B and B greater than C. Okay, do something. Okay, so let's try to display this code. Okay, so we'll put it over here. We'll put foo.php. So this is the code we want to display. Now let's go and again display it. What's wrong? Something's wrong there. What's missing from my code that's being displayed? The IO stream. It got gobbled. It got gobbled because the less than confused the browser. And it thought it was the start of some tag. Specifically, it thinks that it is a tag called IOStream, which it is unable to deal with. Okay, now, do any of you know how Dr. Plank deals with this issue? Because you see this in his code fragments all the time. Dr. Plank deals with it by putting spaces here. Okay, because it no longer thinks that it is a tag. With the spaces between it, it's no longer fooled into thinking it's a tag. But there's a better way, which is that you just use entity codes. Okay, and you always terminate an entity code with a semicolon because that delimiter tells the browser where the entity code ends. Okay, so now if I do it, it shows up all nice. Okay, you can run into the same problem with greater than signs if they happen to be, again, no spaces and there's stuff. I think now this might go wrong. Yep. Because again, there's no spaces there, so it got rid of the, see, it's A less than B, but I put no spaces, so it got rid of that whole thing. So I have the opposite problem, which is what Code Assessor is actually doing, is it is using entity codes to show this stuff. Okay, so that's what Code Assessor under the covers, that's what its page source looks like. Okay, so now this is coming into my back end, and do you think this code compiles for me? No. So actually what I do is the opposite of sanitizing it. I desanitize it by running it through HTML decode entities, and that replaces all of these entity codes with less than and greater than signs and makes it a compilable program. So I actually am doing the opposite with stuff that's coming in. I am decoding it so that it turns it into a legitimate C++ program. Then when I pop it back to the user, I run it through HTML entities so it, again, replaces the less than and greater than signs with their entity codes, and it displays properly in the browser. Okay, so questions about this, about cross-site scripting attacks or HTML entities and HTML decode entities. Okay, so that's one kind of attack you're trying to foil. So it's not just enough to type check it. Typically, you will run a string through HTML entities to get rid of harmful HTML tags before you run it back to a user. Now, you also want to avoid what are called SQL injection attacks. Okay? So, a simple thing is actually not an injection attack. This actually occurred to me also early in Code Assessor. So, another common thing to do in a program Okay? So you'll notice that there's quotes there. Perfectly legitimate code. Okay, so on the back end, one of the things I want to do is insert this code. I want to save your work. So I want to insert into student work say values $code. Okay, and the way I do that in PHP is it's actually, we'll get to this, but I do it as a query. Okay, something like that. What do you think happens to my query when I try to insert that piece of code into the database? What can happen? What happens when it hits this quote? Thinks it's the end of this query. So now the program crashes because there's a syntax error after it. Okay, because when it gets fully expanded, it thinks the query only goes up to here, and then it thinks that at the end of it, there is something that is Brad, like that. And so it gives me a syntax error. Okay, so that's a problem. Well, if you're a hacker, maybe you do something a little more malicious than that. Okay, now it comes in, it terminates the thing, and after this colon right here, we have another query. Whoops, let's do this. Now we have another query that looks like you can do, you have to do stuff. I'm not an expert at this because I'm not a hacker, but you can play with it. I guess you have to do this. And it will translate into this. Okay, and what happens? All the student work gets deleted from my database. That's an SQL injection attack. So someone has taken advantage of the fact that I wasn't cautious enough about the quotes, and they terminated the string, and then they injected some malicious code that messed around with my database. So that's called an SQL injection attack. Okay, so an SQL injection attack is, I have a good definition for it. Well, prematurely, a hacker prematurely ends an SQL query and starts a new query with malicious code. Okay, well, there's a very simple way to stop that attack in PHP, and that's to use a function called add slashes. Okay, so before running an SQL query, run the user data through the function add slashes. What add slashes does is it adds a backslash in front of SQL characters that mean something, like quotes, double quotes, and single quotes. So it also is what I need to do with Code Assessor. When I insert code, your code, into the database, before I run this query, I actually write $code equals add slashes $code, and that adds backslashes to it. Okay, so again, let's just show this to you. Make sure this works. 7G. Am I what? What am I?
Code equals all of that string. You're not terminating it.
Yeah, I am.
That one, level.
Oh, you're right. I'm not terminating that one with a semicolon. Thank you. And there we go. You can see that backslashes have been put in front of the two quotes. So now, when it's put into the SQL database, it comes in with the backslashes in front of the quote. So what do you think I do when it comes out of the database? There is a command called strip slashes that I call to strip the slashes back. So right there, strip slashes, that removes the slashes before I send the string back to the user. So they provide a number of useful. Here's another one that I sometimes have to use, this new line to breaks. Typically this isn't a problem, but sometimes I get back output. Actually, I get this back a lot from the compiler. Get back output in Code Assessor, and it has new line characters. How does that get displayed in a web browser? As one big long horizontal line, because it ignores new line characters. So this NL to BR is new line to break. It replaces all new line characters with a break markup, and that way, like your standard output or the compiler error messages come out in Code Assessor with new lines rather than all on one line. This was all very frustrating when I was first dealing with Code Assessor because I had all of these issues. So PHP has a lot of very helpful commands for stopping attacks, for helping you with formatting. This is just a sampling of them. There's a bunch of other ones that are there too. So for example, strip tags. If you really want to stop someone, you can strip all XHTML tags from a string, but that may not be what you want to do. Usually you just want to convert them to entity codes. Okay, so questions about any of that? Yes?
Just kind of like a side remark that it's pretty widely accepted to use prepared statements to prevent SQL rejection.
Yes, so we'll get to prepared statements on Thursday. So yes, there is a form of SQL where you can, so if I'd known about those, I would have used them at the time, but I did not. And then this is also true of developers. I don't have time to go back and replace them with prepared SQL statements, but that's for Thursday. We'll get to them. Okay. Okay. So last thing. So we've talked about form handling. We've talked about attacks and how to stop them. Last thing we're going to talk about today is session management. Okay, so the issue, I'm going to repeat it and write it down. The issue is that state information is lost as soon as a script, as soon as a PHP script terminates. And sends its page back to the browser. So this is annoying. Let's say that I'm ordering pizza, and the first page took my order, my toppings, the size of my pizza, where I want it delivered. And then the second page that comes up collects my credit card information. And then the third page wants to echo back my order and make sure that it's correct. Well, the problem is that as soon as I sent back the second page, which contains the credit card information, I've lost all the information about the toppings and the size pizza and the delivery address. Okay, that information was lost as soon as the PH script terminates. But that's no good. We need to maintain that information throughout the duration of the user's interaction with us, which in this case involves ordering a pizza, providing credit card information, confirming the order, and then cleaning up. So we need to somehow maintain the state information between page requests. Okay, so somehow we must find a way to save this information between, I'll call it actually script invocations. Okay, there's 4 approaches to session management. Okay, 2 are client side and 2 are server side. 1 is cookies. 2 is something called hidden form elements. On the server side, you have PHP sessions, and you have databases. In the early days, cookies were probably the most commonly used technique for session management. But they've gotten a justifiably bad name as a way for sites to track you and to put information on your computer that you don't want to be there. And so many people turn cookies off these days. Don't allow a browser to even put them on their computer. So most management is done with either hidden form elements or with server-side session management. And for the most part, it's server-side session management. But you should be aware of how each of these things work. So we'll start with cookies because they're kind of the old traditional way. Okay, so cookies are key value pairs that are stored on the client and are sent back with each page request. So when the browser sends a page, the form data back, it also sends the cookie info back. And that is put, in PHP at least, into an array called $_cookie. Okay, it used to be that, at least on the Mac, you could look at these files because cookies were actually stored as plain text files. But the more recent releases of, I'm guessing, Firefox have put them into binary encoded files. So recently I haven't been able to look at them anymore. But you can set them in PHP with the SetCookie command. So let's have a look. So here we have something where we are, actually this one's not doing it. Sorry. This one is. So actually let me show you cookie1.php first. So it's just asking me for pizza toppings. Don't worry about this just yet. I'll show you in a moment what that is. Well, actually you can see it's got a bunch of, shows the cookies that are currently accessible to me, including a session ID that we will get to in a moment. So I'm going to enter my favorite color, purple, and send the form. Okay, and it says current cookies. Now the cookies show up with a delay, so you won't see any cookie for color yet, but there is one. If I go back, you can see that now when it loaded up my cookie for color. If you go and look at cookie.php, you can see that the first thing I did in that PHP file was called a function called SetCookie, gave it the keyword favColor, assigned it the value that the user typed in, and gave it an expiration that is in 1 hour. So the time is in seconds, so time returns the current time, and I said this cookie expires in 3600 seconds, which is 1 hour from now. So in 1 hour, the browser will remove the cookie from my browser and it won't be there anymore. So, couple things about cookies. Okay, SetCookie is the function that creates a cookie, and it only works if the browser accepts cookies. Not, it won't succeed. It must be called before any markup or before any output is generated. So all SetCookies should go at the very beginning of your PHP script. it turns out that cookies are sent in what is called the header information for a page. So when the page is sent from the server to, the way things go is the server sends a page. Okay, sends page. Okay, header information has cookies. Okay, the browser stores cookie information, and then it sends back with each page request. Now, I'm actually not completely familiar with the ins and outs of cookies, but I believe that is this cookie that I created right now would be sent back to any page that to any site that the browser serves a page to. And the reason is I did not restrict the namespace of this cookie. So if you go into my notes, you will see that this function, SetCookie, takes additional parameters, one of which is the domain in which the cookie is available. So most sites, when they send a cookie, they will limit the domain to their site. So, for example, the New York Times, constantly sending cookies to my site, and but it says that the domain is nytimes.com, so that the only server that's allowed to get that cookie is nytimes.com. The browser won't send it back to any other server. Whereas the cookie I created right here, this cookie will be sent back to any server. Okay. So in fact, I think I can look at it. I'm going to go to privacy and second. Have something about how to get my cookies. Huh. Here we go. Okay, so there you can see cookies. So site and the different sites that have actually put cookies on my computer. So the National Park Service has put on 2 GA and NPF newsletters shown, nsf.gov. These are the cookies it sent out. Here's the New York Times. So these are just different cookies with, and you notice each of them has a domain name, so these cookies would only be sent back to that particular domain. And I'm not sure, let's see, UTK is the one that just, do I have UTK here? There we go. But it's actually not showing favorite cookie. So I'm not sure where fav cookie is. But somewhere it is sitting here right now. Okay, so if you do use cookies, the bottom line is that you should be respectful and limit their domain to your particular server domain. Okay, so you should limit who uses that cookie to your server domain. So, cookies do have a number of advantages over sessions. Okay? Second. Okay, so the first advantage that cookies have, so cookie advantages, is that they do not require, well, they work with multiple servers. You'll see in a moment that that's a problem for PHP session management. Just checking. Hello? There we go. Okay, so they work with multiple servers. Two, they are available across sessions. So you can close the browser, reopen it, and they're still there. So they are available across multiple sessions. Okay, so user can close the browser, reopen it, and they're still there. And the third advantage is that both the client-side scripts and server-side scripts can access them. So both client-side and server-side scripts. Okay, whereas with server-side information, only the server scripts can get access to it. So those are the advantages of cookies. Okay, disadvantages, people abuse them. Two, they can be hacked. So hackers can get in and change the values of cookies, which means the server is getting flawed data. So cookies are unreliable. Okay, so I'm going to skip over hidden form elements right now and skip directly to PHP session management because you need it for the homework assignment that's due Thursday. So PHP session management, what you do is at the start of the script, call the session start function. No parameters. What that does, if this is the first time that it's been called for this session, it generates a unique session ID. So if first time called for this session, it generates a unique session ID. It also creates an empty global array called $_session, which is going to be accessible, which will contain your session variables. If it's not the first time, so other times, okay, the session ID is used to locate cache data for this session on the server and initializes $_session to this data. So the bottom line is you call session start at the beginning of all PHP scripts if you want session management, and you then add your key value pairs to $_session, and any key value pairs you add to that array will be available to future scripts. Now, the way it tries to, I'm going to run over a couple minutes, but just a couple, the session ID it generates is pretty hard to guess. So if we go back to cookies, CGI bin. What do you mean it's not available? Yeah, I think you're right. Cookie 1, thank you. Okay, you see the session ID. That's a pretty gnarly key. So what is happening is if you have cookies, the page that is sent to the client has this session ID sent as a cookie. It is nearly impossible for a hacker to guess at these IDs. So it's going to be almost impossible for a hacker to change the cookie to point to someone else's session. So this is a pretty secure session or pretty secure key being sent over to the client side. If the client does not permit cookies, then this ID is appended to the end of any URL that is sent as a link. So any form data, so for example, if you have a form that says action equals, say, foo.php, it's going to modify that link so that it actually has foo.php and this enormous session ID on it. And then anytime you click the action, that will be, or any link, so any link as well, so anything that has an A tag and which links to your site, utk.edu, it will attach a information tag to it that has this session ID. And so when it comes back, the page, that session ID will be accessible as form data, and it can get at it and retrieve the session information. So even if the person disables cookies, there's techniques PHP can use in order to handle it. And the advantage of the session variables, I'll just quickly write them down, is advantages. They are secure. Okay, or more secure than cookies. 2, they, the server, so your session data size is constrained by the server, not the browser. So typically you can have more storage. And it reduces the data traffic. between client and server, because with cookies, you're always sending the cookie information back, whereas with it being stored on the server, there's no need to send that information back as part of the page to the server. So those are the three advantages that PHP session management has. So next time I'm going to finish up by talking about hidden form elements, the disadvantages of PHP session management, and how that's solved using databases. And then we're going to go into how you deal with databases using PHP and XML, which is an alternative form of data storage to relational databases. So you now have